I think I will start then. So welcome to this Media Futures seminar. I'm Björn Tessem from the University of Bergen. I will host this seminar. First of all, I will inform you that the presentation part of the seminar will be recorded. But we will stop recording at the question and answer sessions towards the end. That would be about the last 15 minutes. Chats are not possible except for the hosts, the hosts and the co-hosts. And then we are ready to present today's speaker. Leo Leppänen is a PhD student at University of Helsinki. He has been working with automated journalism for a while and is now in his final stages of his PhD. The title of his talk is Natural Language Generation, Automated Journalism and Finding the Middle Road. So please, Leo.
Thank you. Okay. Yeah, so essentially my plan for this talk is to talk a bit about my experiences in building natural language generation systems for automated journalism, and especially to contrast the types of systems I've ended up building into what I view are the most common systems used in the media industry, the most common types of systems. The types of systems I'm describing are not unique academically, but I think they are rare in terms of what's being actually applied to journalism specifically. Before we get any further, a few caveats. First of all, I will be saying some things about what the industrial players are doing and so on and so on. Quite obviously, the commercial players in the NLG field and in the journalism field are not too hot on telling the world exactly all their trade secrets. So a lot of the things I say about the industry field is based on sort of informal discussions I've had with people and partially on conjecture. So it's completely plausible that there are some industry players I've not had discussions with, and they might be doing something completely different than what I'm saying here. But this is to the best of my knowledge. Also, I'll have a slide or two where I talk a bit about legal stuff. And on that side, I must emphasize that I'm not a legal scholar. I've been working with legal scholars who I'm going to paraphrase and describe the things we've done with them, but I'm not one myself, and I'm not a lawyer. So please do not take this as being sort of competent advice on that field on my part. Any mistakes are mine, and anything I get right is thanks to the excellent efforts of my colleagues. Let me like so. So before we get any further, let's have a brief chat about what I mean by automated journalism. A lot of you might know this also by the name robot journalism. I have a bit of a philosophical problem with the term. To me, a robot is something physical, some sort of an physical machine somewhere that does something. And obviously, when we are dealing with computers, there's no such physical thing and so on. We could also be talking about the use of AI methods in journalism. That was something I considered as a title for this talk and as a title for my PhD, in fact. But that seems a bit vague. I'm struggling to come up with a good definition of AI that wouldn't also include the spam filters and the spell checkers used by journalists. So we'll go with automated journalism. And the specific definition I'm using for the purposes of this talk is that automated journalism is the automatic production of text from data for journalistic purposes. Or phrased maybe in the computer science way, the application of natural language generation research for journalistic purposes. That, in a way, just kicks the can down the road. But by natural language generation, I mean the act of producing understandable texts in some human language from some underlying non-linguistic representation of information. And I think this is maybe the key point that I'm trying to get at with this definitional stuff, is that I'm talking about systems that take something that's non-linguistic and turns it into a linguistic thing, into text. So I'm excluding from my definition machine translation and summarization and rephrasing and many potentially interesting tools that could be used in the media houses for great benefit, but they are not in my research focus. So we are sort of looking at this more tightly defined thing. Another thing that I want to get out of the way is that intuitively, when we think about automating journalism, we might think that the target audience we are producing text for is the general public, that we are producing text direct to the audiences. And maybe there's a human involved as a maker of a final sanity check. But largely that the human is out of the loop. I argue that that's too narrow a view. And it's important that we also consider systems that produce text for journalists themselves. I've been using the terminology systems that build story blanks, where blank is a term used in metalworking usually, where it's sort of piece of material that has been already processed a bit, but it's intended to be processed further. So in the context of journalism and automated journalism, this would be producing something like a first draft or producing some text that the human can then continue working on, and then that the human can then build something better from, rather than having to start from a blank paper. This naturally then ties to the idea of using automation and automated journalism to produce news alerts for journalists, highlighting potentially interesting things, saying, hey, look, there's this data set updated, and this seems to be the most interesting point about it. Perhaps that's something that you as a journalist would be interested in writing a news story about. And finally, there's obviously a way of combining both of these things. Given sufficiently good system, we can automatically publish the first draft of the story built by the automation and sort of plant the flag or get first on the scene, so to speak. And then have a human journalist go and extend that piece and refine it, add more detail, maybe go interview people and so on and so on. So my main point here is that we do not have to limit automated journalism to something that replaces the human. Instead, it can be a tool for human, or it can be a cooperative procedure with the human. I think that's a really important thing to keep in mind when we consider what kind of requirements we have for these systems. So when we think about how automated journalism is practically done in reality, my understanding, and this is referring back to the caveat at the start, is that in a lot of cases, the industrial players are using what I'm calling story templates. Basically, this specific example is from a system by YLE, the Finnish state newsroom, and it's producing a news report about an ice hockey game. And here a programmer and a journalist together have gone and defined highly specific rules how the story should start based on how the first few goals of the game have happened. So there's a separate starting paragraph if the away team got a huge lead in the first half or first period, and a separate starting paragraph if the home team got one, and so on and so on. And this is just everything on the screen is just variations of the start of the story. And the pair of a human journalist and a programmer have gone and figured out, okay, what are all the possible starts for this story and when do we use those? So basically, these story template systems, they produce news text using these large, complex handwritten rule sets that govern what text is produced in any given situation. And the sentences and paragraphs that are produced are mostly canned text, meaning they are mostly pre-written by a human, and they have essentially slots cut into them that then get filled with pieces of information from the underlying data. So in the example below, the number 15.2 and the location name Oslo would come from the data, but the rest is handwritten by a human. And in a lot of cases, these snippets are much longer than a single sentence. They can be even paragraph length sentences or paragraph length texts, out of which these stories are then pieced together. If you are familiar with the concepts of a choose your own adventure book, and I believe the game is called Mad Libs, where you choose different adjectives to create funny stories and so on. This is in a way a combination of those two. There's a choose your own book of how one creates a new story, and then there's a Mad Libs thing where pieces of the data get filled into the thing. These approaches, they are common for a reason. An upside is that you get these kind of methods you can use easily to produce narratives, for example, for ice hockey games. And they importantly require relatively little theoretical knowledge to set up. You can get by with just hiring a programmer and hiring a journalist and asking them to get together and figure that stuff out. You don't necessarily need deep linguistic knowledge, for example, to build these kinds of systems. And also within the constraints of the system, the produced texts are fairly high quality. The downsides then that have been well explored by researchers such as Carl Gustav Lindén are that, first of all, these systems are really difficult to transfer between different languages and domains. You build the system, and then it's working really well for that one thing you built for it. But then you want the new system for another thing that's sort of adjacent, and you have to start from almost the scratch. And that's really impractical for all these media houses and these industrial players, because you are not able to sort of take advantage of the stuff you've done before. Another downside is that the complexity of the rules that are needed to drive these systems exponentially increases with domain complexity. There are only so many archetypal stories you can write about an ice hockey match, at least sort of a normal ice hockey match. But if you start talking about more and more complex new stories, there are then more and more possible story types that you have to account for, more and more possible things that you have to account for. And finally, introducing variety, especially variety in the order in which the information is presented in these systems, is rather time costly and difficult. Because of these problems, there's been a lot of interest in what's the hot new thing in the NLG academia, which is using neural networks for producing news articles. This is something that's still sort of extremely popular in the academic side as well, whereas the previous thing is academically sort of old-fashioned. When we are using neural networks to do NLG, we usually use some kind of an encoder-decoder or transformer architecture, effectively treating the NLG problem as a translation problem. So we are saying that, well, this is kind of the same as translating from one language to another language. Instead, in this case, we are translating from data to human text. And these are then trained using these data sets of paired text and data. Given this data, we expect to get back this and this text. The upside of this approach is that these architectures, they seem to be at least largely domain agnostic. You can apply the same architecture to a lot of type of text generation. Training these systems doesn't really require any expertise in journalism, which is maybe an upside. and the outputs are potentially highly fluent and varied, which is a really big upside here as well. The major downsides then are that you need a lot of training data to train these systems, and that training data might just not exist. It's easy to build one of these systems for a domain where a newsroom has been already producing those types of stories for a decade or 2 decades. But if you then try and figure out how do we introduce this kind of a system to something that's not done before, then you have to somehow get all that training stuff available. Another downside is, at least in my view, that these kind of systems are hard to correct for errors. You train up a system, then you identify there's an error, and what do you do to fix that error? Well, you could get more training data and retrain the system, or maybe you change some parameters and retrain the system, and then you kind of just hope that the error goes away and you haven't introduced a new error instead. And finally, and most importantly, it's really hard to ensure that these kinds of systems produce text that is faithful to the data, the underlying data. The term used for this in the literature is called hallucination. And this is a bad quality example, bad quality in the sense of the image I'm using here has bad resolution, from a news story written by a system by Leppänen and others. I believe this is describing an NBA game. And the contents are not that important. What's important is that there are various colors in the text. And all the green stuff here, that's information that the authors have identified that, yes, these bits are correct with regard to the underlying data. This is all correct. And then you can see there are a few red bits, and those red bits are the clear mistakes the system has done. There's, in one case, the system has said, produce the name of one team when it should have produced the name of another team, and these kinds of things. Thankfully, those are fairly rare in the scope of the text. But the most problematic part is everything that's in blue, and that's what what's labeled as hallucinated content. And the problem is that content, all the content is blue, that is in blue, it might be true, it might be not true, but there's nothing that tells us that in the data. Essentially, the system has made up all the stuff in blue. It has seen that other texts that are similar to this usually have sentences like these, and then it figures that, yeah, I'll just ignore one, include something like that here as well. And that's really problematic from a journalistic perspective. I would say that's like a catastrophic failure. And there's a lot of work that's currently ongoing into fixing this hallucination problem. More recent systems are much less prone to hallucination, but it's not a solved problem. And that's, I think, one of the big things that's holding back the adoption of these kinds of methods. So if we then think about these story templates that are the way that news automation has been done for a long time, and then these neural networks, especially these end-to-end neural networks that are, I would say, the hot new thing, and view them in the context of how the NLG literature is written, we see this interesting phenomena where we have systems that are essentially in the far ends of this one continuum from, I would say, rule-based good old-fashioned AI systems to neural systems. But then again, on the axis that can be identified from the NLG literature regarding how those systems are built, whether you build one big blob of code, one huge system, or in the case of neural network, one huge neural network that just does the thing, or whether you try and build your system in a modular fashion, we see that both of these things are in the global unified end. So that you have one system that has just there's not really any modularity to these systems. Whereas in the NLG literature, there has been a long time, there's been a lot of works exploring this modular end of the spectrum, especially the modular rule-based spectrum. And one of the sort of really famous systems of this type is or architectures of this type is by Reiter and Dale in their 2000 book, Building Natural Language Generation Systems. And the idea behind these rule-based modular systems is that we usually view natural language generation as a collection of subtasks, and then build software that is a pipeline of modules where each module handles one subtask. So in the case of the Reiter and Dale architecture, we would have first a module that determines what abstract information do we want to include in the text, like completely separated from the actual natural language expressions we want to use, just what pieces of information do we want to include. Then we conduct text structuring, where we decide in which order do we want to have this piece of information expressed. Do we separate them into paragraphs, for example? Further stages do things like aggregate pieces of information into, so multiple pieces of information into a single sentence to produce more fluent text, for example. Lexicalization deals with deciding what words do we use to express these pieces of information. How do we refer to various objects, entities in the text? For example, if we want to mention a person, do we use their full name or maybe only the last name, or is a pronoun sufficient, and so on and so on. And then there's a final stage that actually takes all the decisions made prior to that and does the actual linguistic realization, turning these document plans into correct text where all the words are in the correct morphological forms, and so on and so on. And the upside of these approaches is essentially that this kind of a modular approach is that you can, once you've built one modular system, when you transfer to a new domain, a lot of the modules can be reused. Other upsides are that the systems tend to be explainable and interpretable. You can figure out what went wrong. Why did the system do something? Because it's not just a black box. And the systems are fundamentally fixable. We can go in and address any concerns we have. And similar to the way we had with the story templates, there's a relatively high and known quality flaw. We know how bad the system can behave, at least to a certain sort of reasonable amount of certainty. We can be confident that, yeah, the system will not mess up worse than this. Whereas with neural networks, we had that problem where it's unclear how badly the system can go wrong. And that can be a huge problem. There are naturally problems with these modular architectures as well, mostly dealing with problems such as, okay, what if one of the early modules makes a decision that's really impractical or even impossible for the later modules to deal with? And again, variety and variability are potentially difficult or expensive to implement. So my work on this field started by essentially taking a look at how can we go in the journalistic context from these story templates towards this Reiter and Dale type of architecture. How can we make this kind of transition? And we did this work in 2017 in the context of Finnish municipal elections. And we built a system that was called at the time Valtteri the Election Bot. The name is a bit unfortunate given my later antipathies towards the using of the term news robot. But in any case, the system produced news stories about these municipal elections in Finnish, Swedish, and English. And we gave the users a huge amount of control over what they wanted news about. The user could either say on one end of the spectrum, I just want to know about the election results sort of in general across Finland. Or on the other hand, the user could say, I want a news article that says how this particular candidate did on this particular polling station. And this gave the readers a huge amount of ability to personalize what they read. And in the system, we built this modular in two ways. So first of all, the system is modular in the way that the Writer and Dale architecture is modular. There are separate software components that do separate parts of the larger NLG task. But also we were able to largely separate the language-specific aspects within these larger modules to separate sub-modules, meaning that we could build one system, and then within that system, we had separate sub-modules or sub-modules of modules to deal with the different languages. So there's a single trilingual system, and that turned out to be really handy for us. What separates most importantly the system from the story templates is that there is no predefined structure to the stories explained or written the system writes. Rather, what we do is we express all the input data as these atomic units of information that we call facts or occasionally messages. And we associate each fact with a short, brief, maybe 6-word expression that can be used then to express that single fact. For example, a phrase like so-and-so got 72 votes in that and that place. Some small, simple expression like that. And then we estimate each of these facts' newsworthiness using taking advantage of literature into how newsworthiness is defined in the journalism side. We look at things like, okay, there's a piece of information. How topical is it? In this case, meaning, is this piece of information about the current elections, or maybe it's something that's from the previous election and was included in the data as additional context? Is the piece of information a statistical outlier? So if we are talking about the number of votes a certain party got, is that number of votes sort of statistically outlying compared to the other parties in the same location? And then we encoded journalistic values, such as what type of a location or an entity are we talking about. For example, in general, we found that we should prioritize things about municipalities because these are municipal elections over other sort of levels of geographic levels. And finally, we also prioritize things based on what the facts are discussing. So because these are elections, we prioritize things like, in the case of, for example, parties, how many seats did they get? Or in the case of candidates, we prioritize things like, did they get elected, over things like, oh, are they perhaps a previous member of the European Parliament, or these kinds of things. And then the system automatically identifies the maximally newsworthy items from these sets of facts and tries to build paragraphs so that, for example, if the maximally newsworthy thing is something related to a specific candidate, we would select that as a nucleus for a paragraph and then build a paragraph that discusses other newsworthy things about that candidate. So there's no preset defined structure to the article. Rather, it's all derived from the data and these heuristics for identifying what's the most newsworthy thing. We did an online evaluation of the thing, quite naturally comparing these things written by the computer to those written by the humans. The human journalists' equivalent text beat the computer system, but as described in the title of our paper, it wasn't quite the landslide we expected. So it turns out that the system, while not equally good, it could produce reasonable quality text. And especially if we consider the case that the system could produce tens of thousands of different news stories in essentially seconds compared to a human journalist who would need half an hour to write one story, then the advantages are rather clear on that end. Another interesting aspect was that in a lot of cases, a lot of the judges were made mistakes in identifying whether a specific story was written by a human or a computer. So there we did this sort of Turing test-like test there. Over 50% of our participants misidentified at least one text. And in a lot of cases, for most of the computer-written stories, around 25% tended to misidentify any specific computer-written story as human-written instead. And that's sort of a surprising result, at least to us. Since then, we've gone to apply the same basic system, slowly modifying the modules to producing crime statistics and news reports, short news reports about COVID-19 statistics and Eurostat statistics. But going beyond these kinds of domains, we have also dealt with things like, or used the same basic architecture and modifications of the system to describe historical newspaper collections to historians or describe online news comments for media houses. And this highlights the way in which this basic architecture we've built is highly adaptable, and we are able to take the same basic starting point and apply it to a lot of different domains without having to redo the whole thing. And that's really valuable to us. And I think that's a potentially really valuable thing to the industry as well. As an example of the type of adaptation we've been doing, we fairly early on identified that the way where we were planning the documents, while interesting and a good baseline, wasn't really the best. The planner was highly limited in what kind of planning it could do within a paragraph is the main point. So we assume that a paragraph has a highly constrained theme, and as long as the contents of the paragraph are talking about that theme, it's essentially fine however we order the things within the paragraph. And that worked really well with the elections and the crime statistics, where we were able to limit these things, but it wasn't sufficient for the other domains. So we ended up producing a much more complicated document planner, which is detailed in one of my recent papers. But the main point I'm trying to drive home here is that we were able to take a look at the system and identify that, hey, this one specific part of the process we are doing is not quite up to scratch. I could then go and look into research into journalism, and in this case, find something called the orbital theory of news, and then build a new document planner that follows some of the ideas expressed in the theory. And then we could just replace that component of the larger system with that new improved version without having to redo everything. And once this improved component was produced for one of the systems, we can, if we want to, replace the same component for all the other systems as well. So there's a lot of interchangeability there. So having gone to this modular end of the field, however you want to call this kind of a thing, I think that that's not a good end goal. And rather, where we started taking step towards with my colleagues, and where I think where the famous middle road I'm in search of actually lies, is in incorporating both rules and machine learning components in a single modular system. Sort of taking advantage of the best parts of the rule-based systems and the best parts of these new rule systems, and trying to avoid the biggest downsides of both. And quite interestingly, there's been in recent few years, there's been a sort of on the neural side, slightly corresponding trend to go slightly more modular. Instead of building one large neural network that just treats the NLG process as equivalent to machine translation, we are seeing dedicated neural network architectures that are introducing at least some separation of concerns. So you might have a different part of the neural network that deals with selecting what pieces of information to include, and another one to decide how should that information then be expressed in natural language. There have also been a few works, I'm aware of at least one, that have gone all the way to the modular end, taking essentially the Writer-Dale architecture and building all of the components from neural networks. And those have been really interesting. So my hypothesis is that we are seeing this sort of movement somewhere towards the center, basically, somewhere where we take advantage of we know well, hopefully in the future, what things we should do with rules, what things we can do with rules really well, and where we can take the best advantage of these neural networks. So to give some examples of the kinds of things we've been dealing with in incorporating neural processing and neural network type processing in a safe way without endangering the quality of the news text unduly. We've looked at how can we introduce variety with word embeddings. So in case you're not familiar with word embeddings, the idea here is that there's a semantic space of words where we can point, we can observe where in that space a word is located, and then we can find words that are highly similar to that word. The similarity is defined in the terms of how are those words used in other texts, but there's a hypothesis along the lines of if a word is used in a similar context than another word, it must be similar in meaning to that word in some sense. So what this allowed us to do is to, for example, automatically identify cases where we can make minor modifications to the output in a way where we can still retain some sort of certainty that the modifications we are making are not completely changing the meaning of the text. So making addition of variety into the text easier without going completely neural. Some of our initial tests on this showed that the results were fairly good in English, but when we tried the same method in Finnish, we struggled with the highly complex Finnish morphology. I don't know if any of you speak Finnish, but the case system is a nightmare to deal with in that case. But at least in the case of English, we were fairly successful in adding these kinds of modifications and adding a bit of variety fairly safely. Another thing we are currently doing is we are trying to use a neural model to learn how we should order the sentences in the news stories from textual corpora. So we are not giving the neural models the freedom to make any changes to the content in terms of what words there are. We are just allowing it to influence in which order do we represent the content. And this is, in my view, one of those sort of in the core of those ways where we can say that, okay, this is something that the neural model can learn really well, but it's safe to do. Even in the worst case, even if it messes up completely, we will get a correct story. The system is not making up content, and that's important. This work is still work in progress, and I hope to have some results early next year. We are also looking at things like how can we use machine translation models to translate the system itself rather than translating the system outputs, the system itself. I won't go into too much detail there because we have still a bunch of stuff to discuss. So what have I learned in building all these systems? Well, first of all, I really honestly think that there is a middle road to travel between these story template type systems that are so common in the industry, and these neural processing systems that are really hip or really in the academia. And there's something between them that is where there's sort of a really productive mixture of the two approaches. And that approach is achieved through building modular systems for these things. These modular approaches allow us to integrate these machine learning approaches in safe ways and use rules where we cannot guarantee the safety of these machine learning approaches. And finally, perhaps obviously, my belief is that because producing ready for consumer text is significantly harder than producing what I call these story blanks, these almost complete texts, I think that's where there's a good potential venue for building systems that are designed to be collaborative with human journalists, rather than trying to completely replace the human journalist in some case. Some other things I wanted to point out is that so far I've been talking about these modular systems and rule-based systems and neural systems from the point of view of what does the technology make sense and what makes financial sense. But there are a lot of other things to consider that are perhaps non-obvious, in the sense that it's non-obvious that these things are affected by the types of systems we build. And one of these is the copyright and intellectual property rights associated with the texts we used automation to build. I was involved in a collaboration with some legal scholars on determining how does the European copyright system align with the use of AI tools for journalism. And one of the main points, at least to me, about this work is the point that in the Western copyright scheme, the whole thing hinges on there being a human author who is sufficiently original to be able to get this copyright. And this has been explored, for example, in a case where a monkey was able to hit the trigger of a camera and take a photo. And there was a huge legal battle to figure out, does the monkey own the copyright to the photo? And the final determination was that no, the monkey does not own the copyright to the thing. And at that point, it becomes much more difficult. Okay, who does anybody own the copyright? What these legal scholars I worked with determined was that as long as we are using these rule-based AI technologies and there's somehow a human involved in making decisions, then the copyright issue is rather a non-issue. But as we start using these neural networks where it's much less simple to point out who is the human who made the creative decisions, who made the original decisions, then the idea of being able to copyright the resulting things becomes much more sketchy. To quote from the paper, for instance, music created by AI without a sufficient link to human acts is not protected by copyright, no matter how creatively commendable it is. And that's something to keep in mind when we are trying to build this news text and these text generation systems. Do we end up in a place where we are building texts that are not copyrightable? And is that something that's potentially like a catastrophic problem for those who we want to use these systems? In the specific case of news text and news publishers, there's an additional complication to the digital single market thing that the EU enabled, I think, in 2019. But the main point is that this is a thing we necessarily don't have to consider, but maybe should consider if we are trying to advertise the things we do as a solution to a problem. Ensuring that we are not just in a sort of producing a completely new, unforeseen problem to the users of the technologies. Another really important thing to consider and to communicate with the people who use these technologies are biases. And in our work with people in journalism and media studies, we identified fairly quickly that a lot of people have this fallacy that by using automation, we completely eliminate the human from the equation, and that by eliminating the human, we end up in a situation where there's no bias in the system. The system is completely unbiased. And well, for somebody who is familiar with these kinds of technological things, it's perhaps obvious that that's not how this works. In machine learning, there's still the human present as provider or creator of the training data. And in rule-based systems, there's still the human present as the person who figured out what rules do we apply. But these things are not at all obvious to those people who use these systems or those people who might be responsible for these systems. And this is a place where, again, rule-based systems have, in my view, a bunch of really good properties in relation to machine learning-based systems, but let's skip that part in the interest of time. And the final thing I'd like to mention is that, especially in the context of journalism, responsibility and trust are things that need to be kept in mind. A few years back, I believe by now, the Finnish Council for Mass Media put out a statement or some guidance on how automation and journalism interact. And one of the things they explicitly stated is that the editorial staff and ultimately the chief editor bears the responsibility for all the effects of algorithms on journalistic content. And that is a really big thing. There's some person in the newsroom where we want to use news automation, and that person is going to be legally responsible for whatever the system does. And talking somebody into taking legal responsibility for something they do not understand, and in the case of neural networks, perhaps even the creator doesn't understand, that is at least difficult. And there's sort of, I would argue there's even a sort of ethical problem there. And again, this is one of those things where I think that using modular systems and using rule-based components in those modular systems gives a really good edge, because they establish these quality flows and these systems can be inspected and corrected. And that's a huge benefit in establishing trust to the system. And the trust to the system is everything, in the sense that if there's no trust, then the system is worthless. That has been a lot of words, slightly rambling words about my experiences in doing automated journalism, and both a look into how I got into where I am and where I think the automated journalism is going, or perhaps should be going. At this point, I'd thank you for your attention, and I'd be happy to take any questions if you have them.
Thank you, Leo. Really nice talk. At least for me, it was very, very interesting, and I hope for the rest of the audience too. So